Hello everybody, I'm DJ Yusen and today we are back again with our APMOPS preparation video. Now, the question that we'll be dealing with today is the 2022 round 1 question 10. So without further ado, let's jump straight into our question Now this question says that I have a semicircle with a diameter AG and it is shown in the diagram below. The entire arc of the semicircle is divided into 6 equal parts by the points B, C, D, E, and F, of course. Now I have DF and CG, two straight lines, and given that the area of this semicircle is 84, now we are asked to find what exactly is the area of the shaded region. Now here we take a look at this diagram directly. It seems that it is extremely difficult for us to solve the question. Why is that so? Here in this diagram, we see that the shaded region is an odd shape. It's an irregular shape that we most likely have never dealt before. Now, what else can we do then when we are dealing with irregular shapes? Do I just give up? Of course not. So if I want to try to solve this question, I definitely have to think about how do I make my irregular shape back into a regular shape. In this case, it seems also very difficult. But we do know that for a large figure, we can try to chop it up into smaller pieces and see what we can do from them. And that is exactly what we can do here. So here, let's see. Oh, what can I do to cut up this figure then? Here, there is one simple way to cut the figure. We notice that this is a semicircle, and we do have the points B, C, D, E, and F along of it. So one thing that we can try is that maybe I want to cut it into a few larger pieces, which is one way from C to O. Oh, now I've cut up this line over here. That means I have one of these sectors, AOC over here. What can I continue on to do? Of course, I can continue to cut it up. Oh, now I've cut the entire figure into 3 pieces. But there is another problem. Cutting into 3 pieces, how does these 2 pieces help me solve the problem? It seems like it is not as helpful as we think. So we try to erase it and we look at what we have already over here. Still, I know that this area of the semicircle is 84. But that's all I know. So how else can I try to solve this question then? Oh, we think maybe just cutting this into a sector is not exactly very helpful. What else can I do? Here, what I can do is, of course, if this sector does not work, I try to cut it into even more smaller pieces. How can I do that? Of course, I can join another line from A to C to form our familiar shape, which is a triangle AOC. Well, why is forming this triangle AOC helpful for us now? Everyone, let's take a look at all of this 1, 2, 3, 4, and 5 different pieces of area in this figure, and we think, how does it help me solve the question then? Alright, time's up everybody. Now we see, oh, wait, in this figure, we do have 2 pieces of the figure being very similar. And those are this small part ABC and also the small part DEF. Why are they the same? Now the question has already told us that, oh, the semicircle is divided into 6 equal parts by the points, and that means the distance between each of those parts. How will they be like? The distance will be exactly identical. So if their distance is exactly identical, then what can I get from this? We also know one more thing, that ABC, from A to C, the distance will be exactly the same as that from D to F. And hence, we can say that those two parts area should be exactly the same. Oh, what else do I know now, aside from just having these two parts being the same? Now, we'll look at the remaining 3 parts in this figure. Oh, what do we have here? We have AOC, COG, and of course the shaded area CDFG. What can we know about those parts of the figure? Here we see we have 2 triangles. What do I know about these 2 triangles? And here, actually, for those of you that have done before, will know that these 2 triangles, AOC and COG, well, they have the same base. Because A to O should be the same length as O to G, as O as the midpoint of A to G. Now, is there anything else that we know? Both of these triangles actually have the same height. So if 2 triangles have the same base and the same height, what do I know about their respective areas? Oh, we know that their areas should be exactly identical also. So for the area of triangle AOC and the area of COG, they are the same. And this is based on the equal height model, where both of them have the same base and the same height. Now, if I know that these 2 parts are of the same and these 2 parts are the same, what else can I know now? Oh, well, if we think about it, what can we do to the entire figure? Well, now we can try to split up the figure into parts that we know, of course. And how would that be done? I can first join a line to C to E. Oh, then what does that give me? It gives me another part that is the same as the part ABC. And what else do I do with the rest of it? I join another line and I get another exactly identical part. But what is the point of doing this? Here we'll know that, oh, with that, I can also join one more line from E to O, and I've successfully split this figure into how many parts? I split into, well, all 3 equal parts. 1 part, 2 part, and 3 part. Is there anything else? Of course, there is. We know that the total area is 3 larger triangles, and of course, there's 3 smaller bows. So that is what we have over here. But now for the not shaded part, what do I know? Just now we have mentioned that COG has the same area as AOC. That means that its area is 1 triangle. And also DEF, it is also the same as 1 singular bow. So what is the parts that are not shaded now? The not shaded area is 2 triangles and 2 bows. And now, what does that tell us about our shaded area? I think all of you will be able to know it now. It's just going to be one triangle and one bow. Then what is the relationship between this shaded area and the total area then? Of course, I think we all can see it. It is just divided by 3. Since 3 triangles, 3 bows is equal to 84, then 1 triangle and 1 bow should just be equal to 28 over here. So now we have successfully solved this difficult question by APMOPS. So let's do a quick recap of what we have did in this figure. Now, if we start off, if I have a figure that is irregularly shaped and I have no idea what to do, what can we consider? The first thing is that we can consider to cut up the figure into smaller parts that are regular and easier for us to find. And aside from that, now if I have triangles that have the same base and same height, then what do we know about their area? Their area must be exactly the same. So with that being said, that ends my short video over here. Here we have an additional practice question for all of you to attempt. Well, if you're done with it, just leave your answer in the comment section below and I'll be glad to reply whether it is correct or not. So with that being said, well, if you have any other queries, feel free to just join our WhatsApp group below and our teachers at Kangaroo Study will be very willing to help you with it. So with that, thank you and bye-bye.